we find out the concentration quenching is observed at 0.5 mole %. This one is the emission spectra of the barium calcium Dy3 plus dope phosphor. This excitation spectra consists of a series of excitation peak, having the peak observed at 300, 326 nanometer, 351 nanometer, 367 nanometer, and 380 nanometer. This excitation spectra shows a maximum excitation intensity observed at the 351 nanometer. So we take this excitation peak for obtaining the emission spectra, and this one is the emission of the Dy3 plus dope phosphor. This emission spectra consists of a two characteristic band, one located at the 481 nanometer and another band is located at the 570 nanometer, which originate from the 4f9 by 2, 6s15 by 2, and 4f9 by 2 and 6s15 by 2 transition. Last part is the conclusion of my present work. We find out that this XRT is well matched with the standard JCP-5. The micrograph shows that the crystallized size are in sub micrometer range. The characteristic emission of the BTS phosphor was centered at the 591 nanometer and 691 nanometer. And Dy3 phosphor shows the emission of 481 nanometer and 570 nanometer. And we find out that this our prepared phosphor might be applicable in the solid-state lighting devices for a sustainable energy. And I am thankful for the organizer for giving me opportunity to present my work in front of you, all of you. If audience have any question, then ask me.
Okay, thanks to the organizer for giving me chance to present my topic. So my topic is based on evolution of magnesium aluminate by chemical route, modified solid state process and its characterization. Myself, Dr. Soumya Mukherjee, assistant professor from Kazi Nazrul University. So what is the objective and motivation? So objective is to study the development of the spinel magnesium aluminate based compound by comparing chemical route with modified solid state process followed by its characterization. And also the motivation is to develop the products which should be techno-feasible with minimum energy utilization. So this is the overview of my presentation. So what is spinel actually? Now spinel are actually class of minerals which was naturally available, but nowadays we can also synthesize in our lab. Now spinel based materials, though popular in metallurgical industries, are found to be very much versatile nowadays in terms of application from various point of view. For example, nowadays it is also applicable in the field of semiconductors, in the field of nuclear technology, as a reinforcement fibers for photolysis materials, pigments, and so many things. And moreover, these spinel-based materials have properties in terms of structural characterization of chemical, optical, and electrical applications. Now, these are the generalized formula, that is the Ab2O4, where A is the tetravalent, B is the trivalent, oxygen is the anion, and the formula, and as per the formula, we are getting the some of the popular chemicals or compounds as magnesium aluminate, iron aluminate, cobalt aluminate, and several ferrites, which are spinel. So this is the structure, generalized structure of spinel-based compound. Now, this is one of the experimental process routes for the solid state process, that is modified solid state that I have carried. Now, for this process, we have taken AR grade material, that is magnesium oxide, aluminum oxide in molar ratio. We have to activate it by means of aggregate motor activation for several hours. In our case, it is 8 hours. After getting the mixed activated powder, we have put for thermal analysis to analyze the zone of crystallization before doing the heat treatment. These analyses have to be carried out so that we should not go for abrupt heat treatment. Otherwise, we have to go for abrupt heat treatment for various series, which is very difficult to do. After getting the powder, we have analyzed for its in terms of phase analysis, morphology, bonding analysis, and band gap for modified solid state process. For chemical route, we have also taken air grade, but this time this is a nitrate as oxidizer in some molar ratio, that is 1:1, with fuel, which is acting as a reducing agent and providing some energy. After mixing this fuel, we are drying the sample, we are getting the gel. That gel, part of the gel is put for thermal analysis for before doing the heat treatment, just like the previous one, so that our heat treatment schedule is not abrupt. In this case, after doing thermal analysis, we have heat treated at 1000 degrees Celsius for 4, 5, and 6 hours durations. It is followed by the characterization in terms of XRD, SAME, EDAX, and FTR, and property analysis, the micro hardness or bulk modulus and apparent porosity calculations. Moving on to the thermal analysis part, that is the thermal analysis part for the milled process, that is the modified solid state. It clearly indicates that the crystallization zone is below 1000 degree and it is coming close to 870. In general, if we do the solid state process, that is the crude solid state process, the crystallization is around 1200, so which is much lesser in compared to crude solid state process in case of modified solid state process. In case of chemical route process, which is carried out with the help of fuel, we have observed the crystallization, initiation of crystallization around 500, that minor exothermic hump. To get the proper heat to get the proper phase, we have increased the heat treatment schedule. We have increased the heat treatment temperature actually. In the intermediates, we are also getting some gamma alumina formation, which is obviously not our interest, but still we are getting since we want to develop the spinel. The XRD is carried out, and we have observed that since by solid state process we have observed it is 870 is almost the initiation of crystallization. We try to get the spinel formation at 900, and we observe spinel formations there, but it's not up to the mark. So that's why we have increased the temperature to 1050 and 1150 for longer duration, so 26 hours and 36 hours, and we observed quite high amount of spinel with some minor magnesium and alumina peaks still present, but those we can neglect out. So majority we are getting a good quality spinel, and the crystalline size have been taken care of by means of utilization Scherer formula, which is 27.98 nanometer, 29.08 nanometer for 1050. For 1150, it is around 35.63 nanometers. For chemical route, we have increased the temperature, although the initiation of crystallization around 500, but we increase the temperature to avoid any unwanted phase since we are utilizing chemical solutions. And we have indexed the peaks as per JCPD's card number, and we have carried out the heat treatment 1000 for 4 hours, 5 or 6 hours, and we are getting spinel. And the crystal size are in the range from 48 to 47 nanometers. So this is the FTR analysis. The FTR analysis clearly indicates the spinel formation where the inorganic parts are coming below 1000 centimeter in the universe. We are getting the existence of cubic magnesium oxide in the range of from 500 to 1000 centimeter, and we are also getting the alumina magnesium oxide bond vibration close to 1100, while some sort of sorbed ions from moisture, which is possible due to atmospheric pressure, and all these things have happening since with the FT analysis carried in place of atmosphere, not in place of nitrogen atmosphere. For chemical route, we are getting almost the same result, especially the metal oxide coordination part, which is clearly around 530 nanometers for aluminum oxide presence. For magnesium oxide aluminum, we are also getting around 677 centimeter inwards, and some peaks are getting for hydroxyl ions, H2O, which is mainly due to the chemical route process, but with duration of the soaking period, more increased duration, these peaks get almost neglected. Now consider, now more focus on the same analysis. From solid state process, we are getting some cuboid structure in some places with agglomeration tendency, but there is no interconnected cracks in general, and they are in the micron range, 5 to 7 nano micron range, 8 to 9 micron range, and close to 10 micron range if we vary the durations and the heat treatment temperature. For chemical route, we are getting not that variation of cuboid to flaky structure, but we are dense agglomerated, and some portion we are getting some interconnected cracks and porosity. EDAX analysis confirms presence of the magnesium aluminum oxide only, and we have calculated the density which is showing for 4 hours, 5 hours, 6 hours along with apparent porosity. These variations are almost in close with the morphological analysis. Since if we observe the morphological analysis for 4 hours heat treated sample, it is much more dense, while in case of 5 and 6 hours, it has some cracks. It may be possible due to the presence of the fuel that we are utilizing, since the fuel is getting evaporated out with the heat treatment. So sometimes some frost is there which may create that porosity, which is in contrast to solid state process where it is tendency to get more agglomerated structure. Now moving to band gap analysis, we have calculated the band gap by utilizing tau relation, and band gap is in the range from 2.85 to 3 electron volt, which is quite close to semiconductor insulating nature, semiconductor insulating nature. We have also measured the hardness value of the chemical route processed spinel sample, and the hardness values for 4 hours, 5 hours, 6 hours are correspondingly 10.52 gigapascal, for close to 4.087 gigapascal, and 5.079 gigapascal. So in conclusion, we can say that we are getting the spinelization which is much at lower temperature below 1000 degree, in contrast to crude solid state process which is around 1200. We are getting for modified solid state is at 870, for chemical load is a close to 500 initiation. And obviously phase formations are getting with more duration for solid state process. It is around for 26 hours and 36 hours durations, while in case of chemical loop the durations of the heat treatment durations are just 4, 5, 6 hours, and temperature close, and all are in the range of 50, within the 50 nanometers. FTS spectra confirms the presence of metal oxygen coordinations that are required, while just hydroxyl we are getting some H2O water stretching more in case of chemical route due to the presence of chemistry and water solution we are utilization. Same from same we are getting some distinct structure. In case of solid state we are getting some cuboid structures, some flaky structures, but in case of chemical route process we are getting more agglomeration tendency, but in some cases we are getting some interconnected cracks also. EVB's analysis was carried out and we are utilizing tau correlation to measure the band gap, and apparent porosity bulk density calculations have been carried out by making pellets which are in conformation with the same morphology in case of solid state, in case of chemical route process, and we have measured the micro hardness which are in the corresponding values from 10 gigapascal to 5 gigapascal. So these are my references. Thanking you for patience listening, and I am grateful to the organizer for giving me chance to present my paper.
Good afternoon, everyone. I'm Dr. Shivananda C S, Associate Professor, Department of Physics, Saram Vishwesvaraya Institute of Technology, Bangalore. So today I'm going to give an invited talk on silver nanoparticles reinforced on silk fibroin, carboxymethylcellulose composite films for electrical application. So the outline of the presentation contains introduction to silk, silver nanoparticles and carboxymethylcellulose, materials and methods, results and discussion, conclusions and reference part. So introduction to silk, we know that the silk fibroin or silk is a very good biomaterial. So since from ancient days, so in this work, we have chosen the silk Bombyx Morris silk cocoons. So this is the raw silk cocoon materials. We have extracted silk cocoons from silk fibroin from silk cocoons. So this is the schematic diagram of the cross-sectional view of silk fibers. So here in the cocoon itself, the fibroin is encapsulated over the fibroin sericin material. Sericin is a gumming material which is coated over the fibroin materials. So we have to extract the pure fibroin materials from the silk cocoon. So here the this is the some image of cross-sectional image. So the inner core shell is the fibroin material and outer is the sericin materials. Through that degumming process, we have extracted the pure silk fibroin materials. So this silk fibroin contains the hydrophilic and hydrophobic sequence of amino acids. So here the yellow color is showing the hydrophilic blank, as well as another one is the hydrophilic blocks. And this is the schematic chemical structure of amino acid residues or amino acid sequences present in the silk fibrons. So say this silk is a completely a amino acid residues. It contains glycine, alanine, glycerin, and tyrosine, phenolphthalein, tryptophan, etc. So on. So then come to the carboxymethylcellulose. So this is the unit structure of carboxymethylcellulose. This is also a biomaterials. So these are very good dielectric behaviors. Even carboxymethylcellulose as well as silk fibron is a very good dielectric materials. And also here the carboxymethylcellulose is a very good applications in the tablet coating, food packaging, so on, etc. And one more is the silver nanoparticles. Silver nanoparticles is a very good metal nanoparticles, which is a wide variety of application in the field of biomedical applications as well as in the optical and electrical applications. So the silk fiber, this silver nanoparticles, this is a noble metal nanoparticles, which is having a very good optical properties also. So for this our work, we have synthesized this silver nanoparticles using the silk fibroin. So here this silk fibroin is act as a
Sorry to interrupt you, sir. Have you changed your slides?
No, I have not
Okay,
changing the
on the
slide.
same slide. Okay.
Yes, this is the third, fourth slide, I think. Is
So
it
it is
visible?
not changing, sir.
It
That
is
is
not
what I'm
changing.
saying. Yeah.
It's not changing.
No. And we
Okay.
are stuck. We are able to see your first slide.
Okay. Actually,
Yes,
now
now
it is.
it's yeah,
It's
yeah.
in the presentation mode. It is not changing. That's why.
No, it's changing now. You can just click the second slide. Like, yeah, it's changing, sir.
Okay.
Okay.
So now this is a introduction to silk. I already explained this. So these are the schematic diagrams of Bombyx mori silk cocoons, as well as the some images of cross-sectional view of silk fiber and hydrophilic and hydrophobic nature of the silk fibroin. This is the chemical structure of silk fibroin. And come to the carboxymethylcellulose. So this is also a very good dielectric materials, and also it is very good applications in the biomedical. We can use for the scaffolds and film forms in order to bone regeneration and tissue engineering, so on. And silver nanoparticles also is a very good applications in the field of optical properties, electrical properties, and biological applications also. For example, anti-cancer and antibacterial treatments. This silver is a wide variety of applications. Then so we have adopted a standard methodology to prepare the silk fibroin solution. So this is the schematic representation of the preparation of silk fibroin solutions. Here we have adopted a standard silk processing method. So in this work, we have taken the raw silk cocoons, we cut into small, very small pieces, and then boiled into hot water for around 1 hour. So using the sodium carbonate. So after 1 hour, we just bring that silk fiber and squeeze it and kept for a petri dish for 1 day in order to dry. Later, we took this dried silk fiber and we immersed in a lithium bromide. So later, for 4 hours, we kept in a hot air oven. So this fiber is dissolved in lithium bromide solution. So this image shows this is the contains silk fiber plus lithium bromide solution. So this contains the lithium ions as well as the bromine ions. So in order to remove this lithium ions, because lithium is a very toxic metal ions, in order to remove this toxic metal ions, we have to go for the dialysis method using the dialysis cassette. So we kept the dialysis method for 3 days by changing the water for every 7 hours. So then we remove the solution from the dialysis cassette. Then we kept for centrifuge around 15 minutes. So here in this dialysis, a very small porous membranes will be there. So through that porous membrane, all these toxic lithium ions will coming out of from the dialysis cassette. So that we get the pure silk fibroin solution for further experimental work. So this is a schematic representation of preparation of silk fibroin solution. Then whatever we get the pure silk fibroin solution, this is a schematic representation. We added with a different ratio of silver nitrate, that is a raw silver nitrate, we are added to the silk fibron solution. So this is purely biosynthesis approach. Here we have not used any kind of reducing or agent. Here itself, the silk is act as a good biotemplate, and it is able to reduce the silver ions into silver nanoparticles. So this is schematic presentation. Here we have exposed this solution to under incandescent in order to increase the reaction process. So later that in this particular stage, we obtained the colloidal silver nanoparticles present in the silk fibron solution. Later, in the next step, we have taken the silk fibroin and the silver colloidal solution and mix with the 10 ml of different carboxymethylcellulose solution. So we made a composite films, that is the pure silk fibron film and pure carboxymethylcellulose film, and with a different concentration of silver nanoparticles is embedded on the silk fibron as well as the CMC composites. So this is the schematic representation for preparation of SF CMC AGNP composite solution via solution costing method. So this is the obtained composite films. So we have gone for different characterization techniques in order to study the properties of these composite films. So then come to the result and discussion. So we have done UV visible spectroscopy. So here we have plotted the pure CMC and silk fibron CMC. We can observe here the pure silk fibron solution, the absorbance peak is around 278 to 250 or 270 range. We can expect the absorbance peak. So this is due to the presence of amino acid residues present in the silk fibron. Silk fibron. So then here the silk fibron plus CMC composites. So we can observe here the absorption band is around 270 to 280. This is due to the presence of amino acid residues present in the carboxymethylcellulose. And with a different composition of AGNPs embedded on or fabricated on the SF-CMC matrix. So we have obtained a absorption band around 400 to 450 or 470 range. So this is due to the formation of AGNPs present in the silk fibron solution. So these are the SPR band, surface plasmon resonance band, which reveals the formation of AGNPs in the matrix. Then we have done FTIR studies and fluorescence studies also. So in the FTIR spectra, we got some functional groups present in the CMC as well as silk fibron solutions. We can observe a peak around here. So this is the 1500 and 1600. This is due to the presence of amide 1 and amide 2 components present in the silk fibroin solution, as well as this peak is due to the conversion of Ag ions to Ag0 because there are several amino acid residues present in the composites, but here one particular molecule, that is the tyrosine molecules, which is very responsible for the reduction of Ag plus to Ag0 nanoparticles. So here the fluorescence studies, we can observe here the intensity of the fluorescence peak is decreases as the concentration of AGNPs increases. Why means, so more number of tyrosine molecules reduces this Ag ions to Ag neutral atoms. So here the intensity of the curve is decreases due to increasing the concentration of AGNPs. Then we have done the XRD patterns. We can observe here the a semi-crystalline or semi-crystalline peak is appeared here. This is presence of the pure carboxymethylcellulose because it is a amorphous material, and another small broad peak you can expect here. So this is also a silk fibroin. So this peak due to the silk fibroin. Again in the composites, a small peak is appeared. It is not visible clearly, but these are the presence of AGNPs in the matrix. So we confirm with a different 2 theta angle, and also we have calculated the crystallite size and also lattice time. So here the silver nanoparticles is immobilized in the composite matrix. So we have done the evidence of supporting document along with the transmission electron microscopy. We get to know that the formation of silver nanoparticles in the composite materials. So these are the parameters we have evaluated using XRD graphs. So we find out the peak position and we calculated the peak width and also crystallite size using the D by Scherer formula. We have calculated the different crystallite size as well as the lattice time. So then we have done the TEM analysis and also atomic force microscopy. In TEM analysis, we can see in the composite films, these are the size distribution of nanoparticles present in the figure A. And here the single nanoparticles with a high crystalline behavior. This shows that the figure itself is a face-centered cubic structure. The formed nanoparticles. Also, we have done the SAD pattern, the selected area electron diffraction pattern. We can get the different Miller's plane, that is 111, 220, 200, 311. This confirms the formation of silver nanoparticles with a face-centered cubic structure. And also, we have calculated the d-spacing, the interplanar spacing in the silver nanoparticles. It is found to be around 0.285 nanometer using image software. And also we have done the atomic force microscopy. We have done the 2D and 3D diagrams. So we got to know the pits values, the sharp peaks is appeared in these 3D diagrams. This is also confirms the formation of AGNPs in the matrix. And also we have calculated the line roughness and surface roughness of the composite films, and we have evaluated and tabulated here. This is the line roughness and the surface roughness of pure and its composites. Then we have done some AC conductivity and dielectric property. Okay, ma'am, I will find it. So AC conductivity and dielectric properties. So here the silk fibron is a very good dielectric behavior. We shown insert figures. It's a very good dielectric behavior. Shows the silver silk fibron. So this is a very good application for the supercapacitor applications. And also we have evaluated the AC conductivity. The AC conductivity value will be increases from 4 into 10 to the 4 of minus 4 Siemens meter to 8 into 10 to the 4 of minus 4 Siemens per centimeter. As the concentration of silver nanoparticles increases in the matrix, the conductivity of the composites also increases. And also we have calculated the DC conductivity as well as Nyquist plot, and we have tabulated the dielectric measurements of pure and its composites. Here the dielectric constant real part and imaginary part tabulated here. And then conclusions, the CMC and silk fibron are two excellent biomaterial utilized in the pharmaceutical and optoelectronic applications. The toxic chemical free novel biochemistry method we have adopted for the synthesis of silver nanoparticles. We have done UV visible XRD and the FTIR and also AFM, TEM. TEM confirms the formation of nanoparticles is found to be around 35 to 40 nanometer with a high crystalline behavior. And also the increase in the concentration of AGNPs in the SFCMC matrix, which very good applications and suitable for wearable electronic and biosensor applications. So these are my references. Thank you.
All. I'm Dr. Vikas Lahariya from Amity School of Applied Sciences, Amity University, Haryana. And today I'm presenting my research study on the sustainable synthesis and optoelectronic properties of the carbon dots for the environmental and water remediations. So basically, carbon dots are considered as a zero-dimensional carbon nanomaterials. They have shown the tremendous potential for the versatile application in the optoelectronic sensing, photocatalytic, biomedical, and the metal ion sensing applications. Basically, carbon quantum dots are the zero-dimensional. They are the spherical in shape, and the carbon, it is just like a core shell type of the structures, which having the core is made up of the carbon. This carbon may be the graphitic carbon core or the amorphous carbon core. It depends on the ratio of the sp2 to sp3 ratio, and the carbon core basically depend on the synthesis conditions on which synthesis route is adopted, and the carbon core, the shell structure, this carbon core is having the abundant of the surface functional group. These surface functional group like this hydroxyl group, carboxylic group, amino carbonyl group, and these hydroxyl and the carboxylic group offer the water solubility, high fluorescent, and the easy and the non-toxicity, or we can say that the biocompatibility. The carbon quantum dots are they are widely known as a carbon dots and the carbon nanodots. They have shown the strong fluorescence property, size dependent energy band gap, and the tunable fluorescence, due to which they are widely used for the fluorescence and the luminescence applications. And these size dependent properties can be optimized or the modulated by using the surface functional group or by using the dopant of the metal or the non-metal ions. So firstly, this carbon quantum dots was firstly invented by as a fluorescent nanomaterials are invented in 2004. Due to their fluorescent nature. Since then, the rapid efforts have been proceeding with this nanomaterial due to its wide applicability in the energy, environment, and the bioimaging applications. So luminescence is the phenomena in which the material emitted the light by the excitation of the different source. In case of the photoluminescence, when the material is excited by the light in the visible or the UV region, then if the material is emitted the light, spontaneously emit the light, the process is called the photoluminescence, which is further classified as a fluorescence and the phosphorescence. So carbon quantum dots or the carbon dots are known for their fluorescence and the phosphorescence, both of the properties. And their fluorescence properties are basically the origin of the luminescence is basically due to their quantum confinement effect, some of the surface effects, and the molecular state transitions. So as we can see from this figure, by the quantum confinement effect, where the particle size is less than to their electron wavelength or the Bohr exciton radius, in which the energy labels are the described, electrons are confined in their energy labels, and the labels are described, due to which the energy band gap is increased. So due to the increased energy band gap, the emitted light can be tuned. Second effect is the surface effect. As we know that the carbon dots have has the various surface functional group. These surface functional group contribute for the radiative recombinations process, due to which the emission can also be modulated. And third one is the molecular state transition, which is referred as a excitonic transitions. The luminescence in the carbon dots has the size dependent photoluminescence property, highly intense fluorescence, excellent photostability, due to which it is used for the photoluminescence phenomena, high quantum yield, and the anti-photo bleaching ability, which distinguish from the semiconductor quantum dots. Sustainable synthesis methodology. As we can see from this figure, the carbon nanomaterials are, there are different category of the carbon nanomaterials, 0D, 1D, 2D, and the 3D. Fluorine, fullerenes is the 0D, graphite 3D, graphene is the 2D, and the nanotube is a 1D carbon nanomaterials. Carbon quantum dots is also a zero-dimensional carbon nanomaterials, and it can be prepared by some of the top-down approaches and some of the bottom-up approaches. Some of the top-down approaches are like the arc discharge method, laser ablation, acid oxidation, and the electrochemical oxidation. And some of the bottom-up approaches like the hydrothermal, solvothermal, microwave, and some of the green synthesis. In all these, basically most of the bottom-up approaches, the initial carbon precursor can be used as a carbon core material or some of the plant-based or the green roots, and in which some of the bio-based plant extract, leaf, that can also be used as a initial carbon precursor. And this type of the approach is also be useful for the sustainable material processing approach, in which the plant-based, like the stems, seeds, roots, leaves, fruits, and the flowers have been used as an initial carbon precursor. They have the abundance of the carbonyl group. Then these carbonyl group can be further based on the synthesis route and the synthesis condition can be converted into the carbon quantum dots, use these different surface functional group. So in the recent past, there are many researchers have done the many efforts to optimize their applications and the properties using the some of the plant-based carbon source like the sweet red potato, grass, fruit extract, and the leaves, and the bio-based. And these type of the carbon precursor are the have some advantages, like that they are non-toxic, they are considered for the waste management, biodegradable product, renewable material, and the energy efficient. So in my research work, I have prepared the two type of the carbon dots. First is the N-doped carbon dots, and second is the P-doped carbon dots. Nitrogen doped carbon dot. This is the pictorial representation of the N-doped carbon dots, in which we have used the sweet lime juice extract, and this fresh filtered sweet lime juice extract is mixed with the EDA, ethylene diamine. This is the rich source of the N-dopant ion, and then the microwave mixture solution was irradiate in a microwave for the 5 minutes, and then the filtered then the final solution was filtered and the centrifuge, and the micro syringe filtered using the micro syringe filter. Then we have obtained this kind of the liquid solution, which is in a daylight. And this is the pictorial representation of the carbon dots, in which there are abundant various surface functional groups are present here. And further, this carbon dot solution were characterized by the different characterization techniques and utilized as a pH sensor. So this is basically the synthesis route for the representation for the different stage of the carbonization of the N-doped carbon dots, here with the sweet lime juice extract. And after the microwave irradiation for the 200 seconds, it looks like this one. And completed the 300 seconds, it is a brown brown color powder form, which was then filtered, diluted in the water, filtered many times, then centrifuged, then again filtered by the microwave syringe filters, and then it is ready to use. And similarly, the same method is used for the p-doped carbon dot samples. Instead of for the p-doped carbon dots, we are using the phosphoric acid for the p-dopant ions. Now, further, the sample were characterized by the transmission electron microscopy, X-ray diffraction, and the FTIR. This is the figure A, B, C, D representing the different structural and morphological characterization for the N-doped samples. As we can see from the figure A and B, these are the samples for the N-doped carbon dots. The particle size is in the range of the 7 to 9 nanometer. That the histogram can be represented from the histogram, and the particles are the spherical, and there are the two different samples of the different amount of the EDA. Sample A having the small amount of the EDA, while the sample B have the some of the large amount of the EDA. That is, the content of the dopant ion is relatively large. So for the sample B have the lower size as compared to the sample A. And from the XRD, a broad peak around of the 19.90, approximate 20 degree, indicating the graphitic 100 plane. And this one is representing that the highly disordered amorphous carbon core. And as we increasing the amount of the EDA, the peak is slightly blue shifted, and appearance of the new peak at the 44.62 is also here for the low concentration of the low amount of the EDA. From the figure T representing the FTIR spectra of all the n-doped carbon dot samples, where the abundant of the various functional group like the OH stretching vibration, we can see from the OHS stretching vibrations, CH stretching vibrations, amine group, which is due to the presence of the EDA, and the bonding with the carbon atom is represented by the CN bond stretching bending or in plane bending vibrations, and the carboxylic group presents are here. Further, the prepared sample were used for the fluorescence, examined by the fluorescence spectroscopy using the UV chamber and the visible light. So the figure A and B are representing the sample, carbon dot sample in the daylight and the UV chamber, and we can see from that the C4 sample has an optimum amount of the nitrogen, and it shows the highly bright contrast green fluorescence, and when it is excited by the UV light, and when the sample were excited by the 440 nm visible light, then the figure C and D also representing when the sample was excited by the 440 nm excitation. So this is the emission at the green emission at the 530 nm, and this green emission is slightly 10 nm shifted as we are changing the EDA concentration, and the color confirmed by the CIE diagram.
Kindly conclude, please.
Okay, so further the sample were utilized for the pH sensor. There the different pH value was maintained by using the NaOH or HNO3 solution, and the sample shows the good result. A series of the n-doped samples were examined, and their fluorescence intensity and the shift can be observed can be observed from the figure with the changing the pH value. The highly intense fluorescence is found for the 5 pH value. Further, the p-doped carbon dots, where we use the p-dopant phosphoric acid as the p-dope for the p-dopant, and this is the TEM image, and this is the XRD pattern. The TEM image shows the particle size, narrow size distribution with the 3 to 5 nanometer, and the broad peak at the 22.3 shows the 002 graphitic plane. This is the FTIR spectra, which is shown the different functional group, presence of the different functional group, and the bonding with the phosphorus atom at the 1178. This peak corresponding to the interaction of the phosphorus with the oxygen and the carbon, and the UV visible spectra. In the UV visible spectra, the two peaks corresponding to the molecular state pi to pi transitions. This is the emission spectra of the p-doped carbon dot. We can see under the UV light, we can see from the naked eye the bright blue emission, and from the photoluminescence spectrophotometer, the light emission is around of the 490 nm, and this is the excitation dependent fluorescence spectra, and the the color of the emission is confirmed by the CIE diagram. Further, the fluorescence behavior is utilized for the pH sensor, where the pH intensity, the fluorescence intensity is changed with changing the pH value, while the emission wavelength remain the same, and the highest PL intensity, fluorescence intensity is found for the pH value for the 3. So conclusion, in this study, n-doped and the p-doped carbon dots were synthesized from the citrus limta as the sweet lime juice as a green precursor, and the EDA and the phosphoric acid are used for the n-doped and the p-dopant respectively. The structural morphological study revealed the spherical shape, particle size within the 5 nanometer for the n-doped and the 3 to 5 nanometer for the p-doped. Chemical composition shows the various functional presence of the various functional group and their interaction with the amine and the phosphorus content group. The fluorescence spectra for the n-doped carbon dots exhibit the stable green emission with the high quantum yield under the UV and the 440 nm excitation wavelength, while the color of emission confirmed by the CIE plot. In case of the p-doped carbon dots, exhibit the blue emission with the under the 440 nm excitation wavelength, and further the both of the sample are utilized for the pH dependent as a pH sensor by the pH dependent fluorescence spectra, and their color emission is changed from yellow to green as we are changing the pH from the acidic to alkaline nature. So these are the references of the work, and thank you for your patience. For more information and the collaboration, you may contact on my email ID. Thank you.